Hello and welcome back to the series of Machine Learning with Python. I am Shruti and I am your instructor for this course. So in this course, we are going to cover the concepts related to the simple linear regression with some theoretical concepts, as well as will implement practical approaches of simple linear regression. So let's begin.
So we have a regression. Basically, regression is a statistical approach to find the correlationship between the variables called dependent variable and independent variable. Okay, so in the context of machine learning, what exactly the let's understand what exactly the dependent variable and independent variable. Okay, so let's consider the equation of line, that is y is equals to mx plus y is equals to mx plus c. Okay, so now here y is called your dependent variable and x is called your independent variable. Okay, so this is the equation of slope of the line. Okay, so why this is called your y is your dependent and x is your independent variable. Let's consider quickly an example. Now let's suppose the value of your x is 2, value of your 1 is suppose 1, and value of your x, let's suppose 2, and constant having a value again 1. Okay, so now here you can see the value of y will be 1 into 2 plus 1 is 3. Now if we change this value and we'll write here a 4, 1 into 4 plus 1, that will get 5. Okay, so here you can observe, if we change the value of this x, the y also changes. So that means it depends on x, but x is your independent variable. So that is why your x is called your independent variable and y is called a dependent variable in this case. So here we are dealing with the dependent variable and independent variable, and there is some correlationship between those variables. So we have to find this correlationship between those two variables using statistical approach, is nothing but your regression. Okay, so in this context of your machine learning, regression is an algorithm or technique that is applied to certain data set. What exactly the data set I already explained you. And we have to find some correlationship between the dependent variable and the independent variable that predicts the outcome of the unknown value. Okay, so here you can see you have a dependent variable and independent variable. Okay, so there is some data points and you have to draw one line which connects to the, or which passes from this data points. Okay, so again here we have this shows you the linear relationship between the dependent variable and independent variable. So you can, from whatever I explained you, from which you can, on that basis you can easily identify which one is your dependent and which one is your independent variable. So okay, so y is represent the predicted value of the dependent variable according to the given value of independent variable. So y is your dependent variable. Then b0 represent the intercept of the line, gives an, or say the value of the function when the independent variable is 0. Then we have a b1 which represents the regression coefficient, which tells how much the value of the function will scale to the independent variable. Then we have an we have a x which represents the independent variable of the function, then this e represents the error the model is creating. Okay, so this. So now let us consider an example. So let us consider an example. So here we have a data set called position, level, salary, and years of experience. Okay, so from which there are regression models. We have to try to fit the line to fit the best line to set the observed data points. Okay, so here we have a data set called position, level, salary, and years of experience. And according to the model, we draw a graph over here. And here we try to fit the best line to set the observed data points. So for if in case of simple linear regression, we'll get this straight line, and in case of your multiple linear regression and polynomial regression, we'll get this curved line. A regression model allows you to understand how the dependent variable changes in response to the change of your independent variable. Okay, now a simple linear regression model has two explanatory variables. One is dependent and one is independent. Okay, so the key point of your simple linear regression is the dependent variable must be continuous or real value. However, the independent variable can be measured on continuous or categorical values. Okay, so there are a simple linear regression model uses a parametric test. So the parametric test depends on the distribution of the data, oftenly say a normal distribution. So it makes some certain assumptions about that data. So here we have a 4 assumption associated with the simple linear regression model. The first one is the linearity. That means it assumes that the relationship between the data points is linear. That is, the plot of the data points shows linear, like here you can see. Then we have the independence. So independence, there must be no relationship among the different values of the independent variable. So value must be unique in this case. Then you have a data points follow a normal distribution. That is, we plot the histogram of the data. We should be able to draw some skew line. So here we are able to draw the skew line. Okay, that is normality. Then equal variance. The variance of the data should be equally distributed. That is, they do not fan out in a triangular fashion. So when your data does not meet your above these assumptions, so you cannot perform a simple linear regression. Rather, you should use a non-parametric test. Okay. So now here you can see we have a simple linear regression. We have to build a simple linear regression model on this data set called position salaries.csv. We take this data set which has two variables, that is, one is dependent variable and one is independent variable. So therefore the data set is a two-dimensional, taking the experience, this years of experience, as your independent variable and the salary as your dependent variable. Okay, so let's perform this simple linear model actually, and from which we are expecting this graph. So here we have to create a simple linear regression model to find out the best fitting line for representing the relationship between those two variables. Okay, let's quickly build this. So first step is data preprocessing. So let's begin with the data preprocessing. So in data preprocessing, we have to import the essential libraries. So here we need NumPy, Matplotlib and Pandas. So we are importing these libraries here. Okay. So I have already discussed what is Jupyter Notebook, how to install Jupyter Notebook in case of your Python. So if you do not watch the videos of Python, so please watch those first, and and then you can begin with this machine learning. Okay, so here we are importing this three libraries, essential libraries say. So NumPy, Matplotlib and Pandas. Next, here we have to, so let's run this. Okay, then we have to import the data set. So here we are performing on the salary data.csv. So we are importing that data set by executing the above line by using Alt Control Enter. You can run the code. Okay, you will get, or the we can read the data set on the Jupyter Notebook by clicking on the or say by exploring this using this data set. Let's print this data set. So you will get this. This output shows the data set which has two variables called years of experience and salary. Okay, after that we need to extract the dependent variable and independent variable from the given data set. So here I already told you the years of experience is your independent variable and the salary here is your dependent variable. Okay, so in the above lines of code, the x variable, we have taken this -1 value. Why? Because we want to remove the last column from the data set. Okay, and for y value we have taken as a 1 because we want to extract the second column and indexing which starts from the 0. That's why. If we do not perform this, and let's say here we write this after the data set, let's see what are the difference you will get. Okay, so let's rerun again these things, and yeah, so you can see you will get this. Okay, so once we have run, we have executed this, and let's just use this head, you will get this. Okay, so this is how you import the data set, and then we have we have then imported the data set, CSV data set. Then we have then extract the dependent and independent variable from the data set, and now if we execute this x, okay, so we will get the output for x variable like this, that is 1.1, 1.3, 1.5, and for y variable 39343, like this, all these values will get here. So now the next step is split the both variables into the training and testing set. So we have 30 observations now. Okay, so above here we have a 30 observations. So we will take the 20 observation for the training set and the 10 observation for the testing set. Okay, so now we are splitting our data set so that we can train our model using a training data set and then the test model using the testing data set. So here we mention the test size as 1/3. Okay, because we have a 30 observation, we will take a 20 observation for training purpose and 10 observation for testing purpose. That means out of 30 we will we will perform a testing on 10 observations. Okay, so that's why 1 by 3. Now let's observe these values. Okay, so here directly you can see, you can observe for the training set and the testing set. Okay, so this 0 to 9, 10 for the testing set and 20 for the training set. Now the next step is, that is the second step after the pre-processing, is the fitting the simple linear regression to the training set. This is the second step, is to fit our model to the training data set. So to do so, we will import the linear regression class of the linear model. This linear regression class we will import from the model called linear model, which is involved in scikit-learn library. Okay, so after importing the class, we are going to create an object of the class. So we are naming it as a regressor. So we will get, here we are using a fit method. So this fit method fit our simple linear regression object to the training set. So in the fit function, we have passed this xtrain and ytrain, which is a training data set for the dependent as well as for the independent variable. So we have fitted our regressor object of the training set so that the model can easily learn the correlationship between the predictor and the target variables. So whenever we are executing this code, we'll get this linear regression. Okay, after fitting this simple linear regression to the training set, the next step is the predicting the test set results. So here we have a dependent variable called salary and independent variable called experience. So now our model is ready to predict the output for the new observation. So here in this step, what I did, so we'll provide the test data set. Okay, so this is the test data set to our model to check whether it can predict the correct output or not. So we'll create a prediction vector called ypred and xpred. So this contains the predictions of the test dataset as well as the prediction of the train dataset. Okay, so ypred contains the prediction of test dataset and xpred contains the prediction of training dataset. So after executing this, we'll get, now we'll execute this step by step. So after executing this code, we'll get two variables named called ypred and xpred, and we'll generate this which contains the salary prediction for the training set as well as for your testing set. Okay, so you can check here and compare the result by comparing the values from the ypred and the ytest. By comparing these values, we can check how model is performing good. So here we have a ypred and this is ytest. So this is the ytest and this is your ypred. So you can compare both the values, and by comparing these values, you can easily check how your model is performing. Okay, so it is good performing. Okay, now once we have checked all those things, we can obtain the accuracy of the data set by using this. So we have passed the regressor dot score xtrain ytrain, from which we will get the accuracy for the training dataset, and by passing this test score regressor dot score x test y test will obtain accuracy for the testing score. Now, fourth step, that is the last step, is the visualizing the training set results. Now, in this step, we'll visualize the training set results. To do so, we'll use a scatter function of the pyplot library. So here, this pyplot library we already imported in the pre-processing step. So here you can see this pyplot library is already imported here. Okay. Now, just a minute. Yeah. So now this, okay, so the scatter function will create a scatter plot of observation. This scatter function creates a scatter plot of observation. So in the x-axis, we'll plot the years of experience, and in the y-axis, we are going to plot the salary of the employee. In the function, we'll pass the real values of the training set. Okay, so which means years of experience, X train, and training set of salary, that is Y train. So we are setting the colors of observation accordingly. So here we are taking a blue color and the red color for the observation. Okay, so here you can choose any colors, not compulsory red and blue. You can take any combinations like green, yellow, like this. You can change the colors here. And please play this all those things whenever you are executing and whenever you are doing or performing some algorithms in case of your machine learning. So it will be more clear to you guys. Okay, so to understand those things, so here you can change the title like salary versus experience and years of salary. Here you can change the titles. Okay, and just observe what you will get the result. Okay, now this is the fun part. So we will visualize we visualize the results in the Python. So there are this different sets. So here we are visualizing the training set. So here the graph represents the linear regression, that is the blue straight line, and for the training set. So the algorithm tries to find the best fit line for our data set. So this line is the best fit the algorithm could find out our data. So this is this line, we can say this is a best fit line. Now let's see how a model predicts the test data. So same we have done for the test data. So yeah. So here we again use a scatter function in which we pass a x test and y test. Okay, now here this graph shows the predictions made by a simple linear regression model. These red dots are the test data, and the blue line represents the predictions made by our model. If you look at this graph, our model made some close predictions to our data. The points on this line. Okay, so these points are their line. Though the prediction is not accurate for some values, that is the dots far away from the line. Okay, so this is the simplest of the regression model. So we'll see other complex regression model as well, like multiple linear regression and polynomial linear regression. So here you will get the training accuracy as 93 and testing accuracy as 97.
So these are the concepts of machine learning with Python. I hope you are enjoying the videos. Please keep learning, enjoy learning, and please do not forget to press the like button, share with your friends, and subscribe the channel. Thank you.